Good morning. This morning we're joined by Catherine Lewis. She's the executive responsible for technology at Mix Telematics, a telematics company that started in Stellenbosch. Good morning, Catherine.
Morning, Tennis. Thank you for the opportunity.
Thanks, Catherine, for joining me. Catherine, so we've come quite a while. I think we met around about 2009, if I'm not mistaken. And
Sure.
Since then, you've actually supported our endeavors at Stellenbosch University. And you also take in quite a number of our graduates and have over the years. Could you tell me what are the type of skills that you typically look for in an engineer, and specifically electronic engineers?
I think for us, it's for me certainly it's the softer skills that are more important. So most important is problem solving skills, analytical skills, ability to people who can work on their own and carry on pushing through the challenges that they have. So for us, those softer skills are probably more important than the technical skills. And it all goes back to that old adage of attitude and aptitude. So when we're recruiting people, we look more for people that love engineering, love coding, people that had computers when they were 10 years old and do it for fun, not people that just want to manage or do stuff like that. So it's those softer skills, people that absolutely love the arts and science of engineering. And then obviously on the more the technical side, it's the languages like C++, understanding embedded systems, microcontrollers, experience on things like Python and C#, embedded Linux. Those are all an advantage. But really the prized competencies, as we call them, are problem solving and people that are results oriented.
That answer of yours has opened up a whole can of worms, something that I've been wanting to address actually. Many of the students who think about studying engineering, electrical engineering, they ask us, should I rather go and do software programming? And you've just mentioned embedded coding, and in the same kind of sentence, you've said that to a large extent, the skills that you require are people who can write software. So there's this continuous debate between hardware and software. Is there place for hardware? So maybe let's start with that. Do you think there's still a space for hardware, especially in the South African industry that you operate in?
Definitely, without a doubt. But there is a blurring, as you say. And so we've got, if we look at our team, we've got like pure hardware engineers that literally design the PC boards and the electronics, and then we've got our embedded engineers and the firmware guys, and then we obviously move into application development and software. So it's across the whole spectrum, but there is absolutely still a place for those hardcore disciplines as well.
Right. And which one of those three gaps that you just mentioned do you find most difficult to fill with competent people?
Probably more towards the software side. So I think, more towards the software side. I think that's just where the bigger demand is. And so that obviously creates a supply problem.
Okay, and when you say software, do you mean application software, not embedded software necessarily?
Both, but I think the application, we're at the moment we're recruiting for both, and there certainly are more people available looking in that embedded space than there are in the software space.
Okay, very interesting. And then can I also ask you, I've seen many of the engineers who complete an electronic degree end up as software developers.
Yes.
This may be an unfair question to ask you, but do you think there's any advantage in coming from an engineering discipline rather than a BSci discipline, or disadvantage if you want?
My husband is one of those, so it's an interesting question. I think we love guys and girls like that have come from the engineering side or like the comp-sci side of things rather than the other side. So there definitely is an advantage, and probably it probably just comes down to the way those people think and structure their code and analyze problems and go about solving those problems.
Yeah, I must say my experience is you really need both in a team, even though those two groupings often bash heads and don't speak the same language. I do think they both address a different part of the same problem.
Exactly.
I want to ask you something else that you're welcome to just not answer if you want. I was wondering about the fact that you are a female executive in a very much male-dominated industry. Could you, and we're very eager as engineering academics, we're very eager to try to improve our, what is it called, our demographics. Could you maybe speak to me about some of the challenges that you faced getting to this point?
Well, I'm very lucky in that the company mix has been, I mean, this is my 20th year in the business, and there's never ever been a ceiling on what I can do or any limitation on my growth in the business. I mean, what I do now, obviously, compared to what I did 20 years ago, is vastly different. But it's certainly, being a female hasn't counted against me. It is a very male-dominated industry, obviously. And it is a challenge for us. And in fact, I was going to ask you about this because we need more women engineers. You know, we've got one female engineer. She's absolutely fantastic, and a rising star in the business. But there's no disadvantage to being a woman in our business, even though it is a male-dominated industry. So I've not, you know, I mean, there could be a few things, you know, but certainly as an individual and at Mix, nothing has stopped me from growing in the business because
that's very interesting. Yeah. I'm a very firm believer that we need exclusively female presidents and prime ministers in the world, because I think that's the only way we're going to make world peace. But I had a week in which I only interviewed female students, and it was surprising. What you just said was actually true for them as well. I could see that they were rising much faster, just because I think they're adding a complementary skill set to the male engineers, which is making the businesses excel. So that's a very interesting perspective that you get. So just on that topic of female engineers, many of our female engineers choose to study industrial engineering, and that is definitely something we want to move away from, to also have some studying pure electronic and hardcore electronic and electrical engineering. We'll get there, don't worry. Could you also maybe tell me, you're obviously in a company that has a nice spread from hardware to embedded software to the application software, and you've got international clients and everything. Where do you see this domain moving in the next 5 to 10 years? Where are the challenges that you need skills for, basically?
Well, I think it's really embracing the trends of things like machine learning and artificial intelligence and edge computing, and looking at how we can leverage those new technologies to deliver greater value to our customers. You know, obviously there are things like electric vehicles is a big thing at the moment for many of our fleets worldwide. Not such a big thing in South Africa, but you know, we've got customers in 120 countries worldwide. So in Europe and parts of Australia and other parts of the world, electric vehicles is becoming a big thing for many of our customers. So that's right now looking at how we can measure that energy consumption, understand the battery health, doing that sort of intelligence around energy management of a mixed fleet where you've got, you know, petrol vehicles, trucks with diesel plus hybrids, you know, whatever the type of energy source is. So that's a current a challenge that we're working through. And then looking further ahead, it's things like autonomous vehicles. You know, when we've got autonomous vehicles, what does that mean for our customers? What is the technology that we need to deploy to, and what are the new problems that our customers are going to solve when it comes to things like efficient fleet operations or security or safety of drivers and things like that. So there's a lot of, I mean, you know, the technology landscape is evolving. It's incredibly exciting. So predicting 5-10 years is actually very hard, but certainly the generic skills that I spoke about earlier are the things that are going to count, because we'll use those skills and apply them to whatever technologies come our way to the advantage of our customers.
Fantastic. I love the fact that you've answered that in a very much a customer-centric way, because I think that's something that's lacking in the way that we teach engineers. They don't focus on what the needs are, but they focus on what the solutions are that they like to bring to the table. I find it very interesting that you've mentioned electric vehicles there, because what has really propelled the space industry in South Africa is the fact that they could use satellites and build a whole system around that. And because satellites have power, they've got communications, they've got sensing, they've got actuators. And I think in the same way, electric vehicles opens up a lot of avenues for further research and development, and even then in the hopefully at some stage manufacturing in South Africa as well. So Catherine, I also want to ask you about what engineering is contributing to your business.
You know, to answer that, I could give you a cliched thing, you know, engineering is core to what we do, and it is, but there are a lot of functions that are core to what we do. But I'd like to rather answer it like this. Mix Telematics has got 750,000, give or take, subscribers around the world in 120 countries. It's actually 150 countries, but some of those have got like 3 vehicles in them. And in our business, a subscriber is basically a vehicle or a mobile asset that has a little onboard computer in it that talks to our SaaS platform. And every single one of those little onboard computers was designed, developed, planned, and is supported and maintained by our engineering team in Stellenbosch. So it's quite phenomenal. I actually just want to show you a picture. If we were at the office now, because we're all working from home, but if we were at the office, let me just share the screen with you, and you came through our building, walked through our building, you would see this picture up on the screen on one of the big TVs. And what this picture is, it's updated every 15 minutes, and it's showing you every little yellow dot represents a vehicle in the world that's talking to our backend, and every single one of those little yellow dots has got a product in it that was designed and developed by our engineering team. And it's incredible. I mean, any engineer looking at that can just see the importance of what they do, and it's a tangible, you know, result of the effort that they put in.
How many engineers do you have? I think I've missed that.
Sure. True engineers, I think we've probably got around 30-ish, and then combined with software, we're probably looking between software developers, engineers, and round about 100.
Fantastic.
And what's great is, like I said, we've still got our principal architect engineers that have been there since the very beginning, and then we've got a bunch of rookies that are engineers in training that have literally just left university now, and a whole lot of different people in between. So it's a very diverse team, but very energized and very passionate about delivering great products.
Fantastic. Catherine, thank you so much for your support of our department and the university in general, and also for giving this fantastic, successful story to South Africa. And well done for doing that. Thanks very much for your time.
It's an absolute pleasure, and it's great working with you guys too. Thank you.